Think about the first time you wrote a code. What was it like?
Oh God, mine was a mess, full of bugs, didn't make much sense.
Exactly. We all remember those first programs. Simple, flawed, but importantly, deterministic. You gave it instructions, it followed them, bugs or not.
So why did we move away from that traditional approach?
Well, traditional programming, it's limited, very good at specific tasks, but incredibly inflexible. The arrival of machine learning was a game changer. It introduced algorithms capable of learning from data without explicit programming, which is a huge shift.
Wait, so in a way, are we saying that machines started teaching themselves instead of being spoon-fed information?
That's one way of putting it, yeah. Providing machines the ability to learn patterns, make sense of information, that was the birth of a whole new horizon of technology.
So, traditional programming is more like teaching a kid to ride a bike with training wheels, and machine learning is like letting the kid figure out how to ride without the wheels?
A rough analogy, but yes, in machine learning we are essentially saying, here are the examples, learn from them. Has anyone ever really explained what machine learning is?
Well, I've heard it referred to as a type of artificial intelligence that's capable of learning and improving from experience.
But isn't that just intelligence? The ability to learn from experience?
That's true, but machine learning is special because it enables capabilities to extend beyond what they were explicitly programmed to do.
Could you expand a bit on what you mean by capabilities extending beyond? I'm not quite sure I follow.
Sure. You see, traditional software operates based on explicit instructions. You input a set of rules, and the program performs tasks as specified. However, with machine learning, instead of explicitly programming the software, you create algorithms that can learn from and make decisions or predictions based on data.
So, traditional programming is like us giving step-by-step directions to a stranger to get to a destination. Machine learning, on the other hand, is more like giving a GPS. It learns the rules of the roads and is thus much better equipped to handle unexpected obstacles on its way.
That's right, Jiwoo. In machine learning, the rules or patterns are not hard-coded. Instead, they are learned from data, enabling the system to perform better as more data is collected.
So, the more data the machine has, the smarter it gets, essentially?
Yep. And just like a human, it's not just about quantity of data, but also about the relevance and quality of that data. Simplistically put, machine learning is all about extracting knowledge from data.
But this does seem slightly beyond the purview of AI, isn't it? We generally think of AI as mimicking human intelligence, but isn't learning from data something even more advanced?
It's a common misconception. The reality is, machine learning is a subset of AI, not something beyond it. It's one of the key techniques that's bringing us closer to creating AI that can truly mimic human intelligence.
Now hang on. Now we understand basic concepts behind machine learning, and with it, can we take a pause and look back at the evolution part? I find it fascinating how concepts like machine learning have evolved over time. A parallel can be drawn to the evolution of computer sciences as a whole.
I totally agree, Jiwoo. The evolution of machine learning is closely tied to the evolution of computing itself. In fact, the history of machine learning goes as far back as the 1950s.
Wait, the 1950s? You're saying we've had machine learning for over half a century?
Correct, Olivia. The pioneering work in the field started back in the 1950s, although back then they called it automatic coding or rule learning. An early example would be Samuel's checker playing program that incrementally improved its performance by learning from its mistakes.
But isn't that a rather simple iteration compared to today's complex machine learning?
In a way, yeah. Perhaps it was simplistic, but it was those early steps that eventually brought us to where we currently are. You see, the foundation of learning from data, fine-tuning based on past experience, all those are still applicable even in our sophisticated models of the present day.
So everything got more refined, more precise over time?
Definitely, Jiwoo. Over time, machine learning has become more efficient and autonomous, thanks in large part to major advancements in both hardware and algorithms. The abundant availability of data is also a major factor. And let's not dismiss the dramatic progress in computer processing power, which has allowed us to push the boundaries of what was once thought possible with machine learning.
Right. So machine learning is essentially a blend of computation and data, evolving together over time.
Aptly put. Olivia. Furthermore, this continuous evolution and booming innovations have resulted in reshaping the entire tech industry. Now, more and more industries are leveraging machine learning for their operations and solutions, which showcases its ascension to being a critical component in various domains. I think it's important we continue our conversation by discussing types of machine learning. As we already dove into the basic definitions and concepts, let's break it down further into supervised, semi-supervised, and unsupervised learning. So, supervised learning, which I'm sure quite a few of our listeners have heard of, is a method where the model is provided with labeled data.
Labeled data. Does that mean the data is already categorized?
Yeah, exactly. It means each data point is paired with a corresponding output value, or label. And the main goal of supervised learning is to learn a function that, given an input, predicts the best fitting output. This method is widely used in practical applications, like spam filters or weather predictions.
Interesting. So that's why when I get a shady email, it directly goes into my spam folder.
Haha, exactly. The email spam filter has been trained on a dataset where emails are labeled as spam or not spam. Moving forward, next up, we have unsupervised learning. In this, we don't provide labels, just raw input data. The goal here is not necessarily to predict an output, but to model the underlying structure or distribution in the data to learn more about it.
It sounds more flexible, but in practical terms, what are its uses?
Great question. A practical case would be targeted marketing. Identifying different groups or segments within a consumer base. Then we have semi-supervised learning, which is somewhere in between, where a small amount of the data is labeled. This method can be very useful in situations where data is expensive or time-consuming to label manually.
I've read somewhere that semi-supervised learning can also be used to build personal recommendation systems, right?
Exactly, Jiwoo, like how Netflix recommends shows based on your preferences. So now we see each method has its own strengths and weaknesses. The key is in finding the right approach for the task at hand. But don't forget, the lines between these methods can blur as they are often used in combination. Let's move on to another intriguing concept, reinforcement learning or RL. Now, this is a bit different from the types we've covered so far. Think of it as a trial and error method of learning. The software agent, interacting with an environment, takes actions based on its current state and receives rewards or punishments.
That sounds like training a puppy. You reward it for learning to sit and kind of scold it when it chews on your shoe.
Exactly. Over time, the agent learns a policy, which is a strategy to choose actions that maximize the sum of rewards over the long term. This is a crucial point. It's not about getting the highest immediate reward, but about maximizing the accumulation of reward over time.
But how does the software agent decide whether it's better to explore new, potentially rewarding options, or stick with what's known and safe?
Well pointed, Jiwoo. This is what we call the exploration versus exploitation trade-off in RL. Exploration is about learning more about the environment, while exploitation is about leveraging the knowledge to get the most reward. Balancing these two is one of the fundamental challenges in RL.
I imagine it's quite tricky to put into practice then.
Indeed. Although RL has had some impressive wins, like mastering the game of Go, full-scale implementations in real-world applications can be challenging due to factors like data inefficiency, difficulty in specifying rewards, and the complexity of the real world as compared to a game. Now we've discussed various facets of machine learning, but let's pivot to another wave that's hitting the AI industry, deep learning. Unlike Olivia's puppy training, deep learning moves a step further. It's where machine learning models mimic the neural networking of human brains.
So, it's as if the machine is developing brain-like processing?
Exactly, Jiwoo. Think of our brain, a complex web of neurons interconnected, passing signals. This is what deep learning tries to simulate, a neural network. Each layer of these networks can learn specific features and pass them on to the next layer.
That sparks my curiosity. Does more advanced mean more layers in this brain?
You're on point, Olivia. In fact, that's why it's called deep learning. Because these neural networks have several layers, or depth, they process inputs through more layers than traditional neural networks. And the deeper the network, the more complex patterns it can recognize.
deep, like when I delve into 3D models. But this deep neural network should take a lot of processing power and data.
Absolutely, Jiwoo. In fact, this was an obstacle initially for deep learning's application. But with technological advancements and increased data flow, deep learning has found its footing in numerous fields, from creating realistic animations to detecting diseases and even powering self-driving cars.
So, if I get it right, machine learning is learning from data, while deep learning takes a dive into neural territories and learns patterns in data layer by layer.
Very well summarized, Olivia. Each of these technologies has its own strengths, and choosing between them often depends on the task at hand, the available data, and the resources one has. Okay, as promised in our last segment, we're now going to talk about machine learning algorithms. Let's start with one of the simpler models, regression. Can you guys visualize a scatter plot?
Definitely. Go on, Chris.
Great. Now imagine trying to fit a line that best represents the scattered data points. Regression, as its name implies, regresses the data, or simplifies it into a linear model. It is the basic building block of machine learning algorithms and is often used for forecasting or predictions, such as predicting house prices and sales forecasting.
But not all data can be simplified into a linear model, right?
Spot on, Jiwoo. That's where decision trees come in. Imagine a tree branching off, at every branch asking a question, eventually reaching a solution or classification. This algorithm is fast, easy to use, and can handle both classification and regression tasks.
Interesting. What about random forests? Anything to do with trees?
You could say that, Olivia? Random forests is essentially a group, or should I say, a forest of decision trees. It's as if you're asking the opinion of a crowd rather than relying on a single decision tree. This technique reduces the risk of overfitting and improves generalization, making it incredibly useful in a diverse range of sectors, from healthcare to fintech.
Fascinating. So through these algorithms, machines are learning to predict and decide, almost like us humans.
Machine learning has made significant gains in multiple sectors, including healthcare. It's astonishing to watch how AI can analyze vast amounts of clinical data to predict patient outcomes, isn't it?
Absolutely, Chris. The healthcare domain felt a whole lot of benefits. ML aids physicians in disease detection, drug discovery, personalized treatment, and patient care. It's a game changer in this sector, transforming lives of patients and easing the jobs of medical experts.
Healthcare is just one example. In marketing, ML algorithms help in analyzing customer behavior and creating highly targeted advertising, thus significantly improving customer engagement and business revenue. Chris, any insights into this?
Apropos, Jiwoo. Customer segmentation, predictive analysis for sales, personalized content creation. All these are made possible and effective with ML. Essentially, it makes advertising less intrusive and more personalized, which is a win for both customer and business.
Interesting. Let's not forget the financial sector. Can you shed some light, Jiwoo?
Certainly, Olivia. ML in finance is all about pattern recognition, credit scoring, algorithmic trading, fraud detection, and optimizing investment strategies are few areas where ML is extensively exploited. Unthinkable tasks are now plausible, thanks to ML.
Absolutely. Now, in education, ML is starting to remodel. It enhances personalized learning experience through recommendation engines, predicting student dropouts, streamlining administrative tasks, and even in developing interactive software for special students.
Indeed, Chris. Lastly, from predicting climate changes to optimizing resource allocation, ML plays a pivotal role in environmental science too. It's truly fascinating to see the stretch of machine learning across various sectors. All these advancements, and we're just scratching the surface of the potential of ML.
To kickstart our next segment, let's discuss how machine learning has infiltrated our daily lives without us even noticing. For instance, think of your music streaming app. Ever wondered how it knows so precisely the kind of music you'd love?
That's thanks to ML-powered recommendation systems, Chris. They learn from users' listening patterns to predict future song choices. That playlist you vibe to, it's ML's gift to you.
Apart from music recommendations, how about those personalized ads you see while browsing the web?
Targeted advertising. It's an effective marketing strategy driven by ML algorithms. These algorithms analyze user behavior to push ads tailored to individual interests. A bit unnerving, but undeniably efficient.
What about social media feeds? Aren't they also manipulated?
Unquestionably, Olivia. ML enhances user experience by personalizing social media feeds. Posts from our favorite friends, videos relevant to our interests, even news stories tailored to our worldviews, all brought to life by the genius of ML.
So, these seemingly inconspicuous facets of our day-to-day life, they're not so ordinary after all. ML has indubitably become the secret ingredient, quite literally in some cases. Ever used a cooking app?
The magical recipe recommendations. Advanced ML is at work there as well, coming up with that perfect pasta recipe based on your past cooking escapades.
Engaging examples, Jiwoo and Olivia. We've illustrated how ML has truly permeated into our everyday lives. It's something we often overlook, but it's fascinating once you start noticing it.
One area where machine learning's influence is subtly powerful is art and entertainment. Don't you all agree?
Absolutely, Olivia. Machine learning algorithms coupled with creativity have given rise to transformative art more dynamic than ever before.
True. For instance, algorithms can now scan through vast amounts of artwork to produce entirely novel and aesthetically pleasing designs. They're even being used to complete unfinished paintings.
That's not all. Deep learning, a subset of machine learning, is now capable of generating original music scores. AI-created compositions are considered unique and inspiring. Innovation at its peak, don't you think?
Definitely, Chris. Also worth noting is how ML is used in literature. Algorithms are now capable of writing compelling narrative, poetry, even entire novels. Algorithmically generated literature can mimic the style of historical authors while crafting unique stories.
Actually, there's something that I'm not completely clear on. How exactly does machine learning learn to create music and art? Can it truly be creative?
Great question, Jiwoo. At its core, creativity is about finding patterns and making connections that haven't been made before. ML does this exceptionally well. By feeding an algorithm a dataset of creative works, it learns the patterns and can extrapolate this into new, previously unseen combinations.
In other words, machines can't be creative in the human sense, since they don't have subjective experiences or emotions. But they can mimic the processes used in human creativity effectively.
That's fascinating. Learning how ML has shapeshifted the creative industries. Honestly, it's slightly intimidating too, considering the speed at which this incorporation is happening.
Yes, Jiwoo, given the growing influence and potential for growth, machine learning is revolutionizing the creative domains in ways we are still beginning to understand. Now, while we're on this topic, I think it's important to also address the elephant in the room, the ethical considerations surrounding machine learning. What comes to mind for you, Olivia?
Well, Chris, an immediately striking issue is data bias. Machine learning models are only as good as the data they are trained on. If the data is biased, the machine will inadvertently propagate these inaccuracies, leading to unfair results, which could be harmful especially in decisions related to employment, law enforcement, or healthcare.
That's a solid point, Olivia. Another ethical concern often raised is privacy. Machine learning can spill over into privacy invasion when put in the wrong hands. Misuse of personal data collected can violate individual privacy, leading to significant societal implications.
These are pressing concerns. It's also necessary to note that the transparency of machine learning processes is important as it facilitates trust and credibility. However, with complex models like deep learning, understanding the decision-making process is not straightforward, which can often cause us to question its ethics.
I want to throw another thing in here. Machines making decisions also challenge traditional lines of accountability. If a machine learning model makes a false prediction, who's to blame? The coders, the data providers, or the machine itself? The lack of a clear answer raises ethical questions.
These are serious questions indeed and need serious thinking. Despite these concerns, I believe machine learning has the potential to offer a lot of benefits. However, it's imperative that these ethical considerations are addressed.
Well said, Jiwoo. It's about striking a balance between benefiting from machine learning capabilities and ensuring there's no compromise on fairness, accountability, and privacy. When we consider the current trends in machine learning, the advancements in areas like natural language processing and predictive modeling are particularly impressive. They present a significant breakthrough, particularly in deciphering human emotions and predicting user behavior. From your perspective, Olivia, what trends are you noticing?
I'm glad you touched on NLP and predictive modeling, Chris. A trend I've been observing stems from my field, the integration of machine learning in art and photography. Generative adversarial networks, or GANs, are being employed to create unique pieces of art. It's fascinating how one can teach machines to create. Jiwoo, any significant trends catching your eye?
Absolutely, Olivia. In the industrial design sphere, we're seeing increased use of machine learning in improving efficiency and optimizing design elements. Machine learning techniques are now beginning to predict optimal design solutions, even before any physical prototypes are made. It's surely a game changer in my field.
Interesting points, both. Considering the future, can we anticipate that these trends will conduct the evolution of machine learning? Personally, I envisage further advancements in algorithmic learning models and perhaps a greater move towards unsupervised and semi-supervised learning. How about you, Olivia?
Well, Chris, one aspect that excites me is the future development of deepfakes, or synthetic media. On the one hand, it can lead to breakthroughs, like hyper-realistic simulations for gaming or movies. Yet, it could also pose challenges like misinformation spread, which we should handle with responsibility.
I share your concern, Olivia. In the future, I expect we might see machine learning playing a critical role in sustainable and smart cities. With increasing urbanization, intelligent systems can optimize resource allocation, reduce waste, and help us combat climate change.
Certainly. Acknowledging both the challenges and potential, it is crucial to monitor the trends and anticipate the future of machine learning. The marvel of AI is rooted in the continuous refinement, improvement, and evolution of machine learning, and we're only just beginning to comprehend its potential. Machine learning, the often understated hero of numerous sci-fi blockbusters.
An undeniable truth there, Chris. It's empowering to see how art and popular culture envision our future with machine learning, even though some visuals can be a little exalted or ominous at times.
And yet, they reflect our existing fears or hopes, don't they? Take the classic Minority Report, for example. It showcases predictive analysis to an extreme, preventing crimes before they happen. Not exactly machine learning per se, but it does hint towards modern algorithms' promise to understand and anticipate human behavior.
One film that struck me is Ex Machina. It's not purely machine learning either, but the AI in it presents an interesting concept of machines learning human behavior and manipulating it, something we're cautious of in the real world.
That's an excellent point, Jiwoo. Her is another film that portrays the concept of a learning machine as a friendly AI companion. But I wonder, how accurate are these depictions?
Some of them are quite exaggerated, but it's what you'd expect, given the fact these films are not merely documentaries but creative works. Machine learning's not about crafting sentient machines just yet, but applying learned patterns for solving specific problems.
Right. And it's important for the audience and us to distinguish between fact and creative liberties. What about machine learning in video games?
Ah, yes. AI opponents in games do use machine learning to analyze player strategies and adjust gameplay. StarCraft 2's AlphaStar by DeepMind can be a perfect example. It beat professional players by learning from playing countless games. Now, any guesses how Omega will perform in the near future?
Not sure about Omega, Chris, but it's exciting to see these evolutions in the gaming world. Seems machine learning's reach into popular culture is larger than we imagined.
Yet interestingly, despite broad usage in popular culture, the fundamentals of machine learning, algorithms, data, predictions, remain misunderstood by many. Olivia, could media be more equipped to educate on these?
Increasingly, Chris. There's movement in this direction, but it's currently limited to explainers and features. With better narrative integration, popular culture could play a huge role in democratizing understanding of machine learning.
Certainly worth exploring. Ultimately, media's similar to us in a way. It's predicting the future based on our understanding, albeit with more creative liberty. Moving into the realm of future predictions, how do we envision machine learning evolving?
Well, in the art world, I think we're going to see more collaborative artworks, driven by AI and human creativity. Through machine learning, arts are bound to get more interactive and personalized, reflecting individual tastes and interpretations.
It's interesting you mentioned personalization, Olivia, because I see immense potential there within the EV industry. Imagine vehicles that not only learn your route preferences, but also your driving style, thereby customizing the entire driving experience.
That's true, Jiwoo. Along the same vein, in healthcare, machine learning might advance predictive analysis for better preventive care. Personalized medicine could be a defining feature of our healthcare system.
Isn't there this concern, though, about how much we should allow machine learning to customize our lives? I mean, at what point does it get too invasive or make us feel less unique?
A valid concern, Olivia. But now imagine, what if machine learning evolves to a point where it can accurately predict major world events, like elections or market trends? Would we blindly trust these predictions?
I'm not sure we could ever entirely trust any prediction, be it from a machine or human. But I believe the key lies in integrating machine learning as a tool, a guide, rather than the ultimate determinant.
Yes, Jiwoo. It's about combining human creativity and intuition with machine precision and scale. There's this beautiful symbiosis we can achieve between humans and machines. The possibilities are truly infinite. So, we've covered an array of topics around machine learning today. Let's conclude with a closer look at our personal interactions. Olivia, your venture with Click AI surely puts you at the forefront of this wave.
It surely does, Chris. Machine learning isn't just a theoretical concept for me. Every single day, we're creating algorithms that adapt to user behaviors and evolve the user experience. We're constantly trying to strike a balance between tailoring to personal preferences and not invading personal space.
That's an important aspect, Olivia. Balancing personalization and privacy is a challenge in EV design as well. Machine learning enables us to create products that are intuitive and efficient, but we should remember the car is still a personal space.
There's that delicate balance in AI again, between utility and privacy, growth and ethics. As we tinker with AI, it's not just about innovating, but also reflecting on the directions we want to take as a society.
I couldn't agree more, Chris, and I think it's a good idea for everyone to stay informed. To help our listeners delve deeper into machine learning, we recommend Neural Networks and Deep Learning by Michael Nielsen. It's free online and can be a good start.
Another interesting perspective can be obtained from the book Weapons of Math Destruction by Kathy O'Neill. It elucidates some undesired outcomes from machine learning. Always beneficial to know both sides of the coin.
Indeed, Jiwoo. Ultimately, it's about tooling ourselves with machine learning and not letting it rule us. Let's always remember that behind every intelligent machine, there's a human spirit of innovation and communion.